Okay, Thursday math. So I've gotten a lot of feedback that maybe I'm assigning too much because I'm trying to do it by hours, and it's not always easy to tell how many hours certain online assignments are going to be. So I'm going to scale it down a little bit today. I'm only going to have you do combining like terms and the distributive property and equivalent expressions. If you do those two today, that'll be your assignment. Okay. So combining like terms, let's see what that is all about. So like terms are terms whose variables and exponents such as n, such as a 2 and x squared are the same. In other words, terms that are like each other. So the coefficients, the numbers you multiply by, such as 5 and 5x, can be different. So see, x is the same in all of these. 7 and -2 are the variables, okay? But these are all like terms because they all have an x attached. So, and here's another example. Only this time it's yx squared. See that everywhere, yx squared, then yx squared times 2, all right? So these are all the like terms, but these are all the unlike terms. These are all the variables, okay? 1/3 minus -2, 6, and this would be 1 even though you don't see the 1 here. So this would be unlike terms because you have a y over here, okay? Then you have a y squared, then you have xy. So those are not compatible terms. They are unlike terms. You can't put them together in any way possible because the variables are different, all right? So these are all unlike terms because the variables and or their exponents are different. So y, xy, y squared, x squared, and then x, these are all different. You cannot put them together. You can't add them. That's about as small as each of those are going to get, okay? So 7x plus x. How would you do that? What would the answer be? Would it just be 7x? Is this like a 0? Is x like a 0 when it doesn't have a number in front of it? No. Whenever there's a variable without a number in front of it, just pretend like there's a 1 in front of it, okay? Because each of these stands for 1, all right? So this would be like 7 times 1, okay? So that's 7. There's going to be a 1 in front of this. So if you use 7x plus x, it's going to be 8x, okay? So you always need to imagine a 1 in front of x. Why don't we write x, 1x? Because it's simpler to write x, and so common that 1x looks strange. Okay. So here's an example. Like terms. These two are like terms, and these two are like terms because they don't have any variables after it. This one is by itself, though. Okay, so if you combine them all, you have 4x by itself plus 3x minus 3x squared minus x squared, and then plus 2 minus 7. Okay, you can put them all together. And this is what you would end up with. So let's go to question number 1. Simplify 8x minus 2x. Now, are these like terms? And yes, so we just pretend we just do the problem. If they're the same terms, okay, then we just do the problem. So 8 minus 2 is 6, so it'd be 6x. All right? Simplify, okay, 6y2 plus 3y2. Put those two together, that's going to be 9y2. Like terms, so it's basically 7 plus 3 plus y, so that's going to be 10y. Now 5z plus z, remember the z has a 1 in front of it, so that's going to be 6z. One more. Remember the x has a 1 in front of it, so 9x minus 1x is going to be 8x. So these are just examples of combining like terms and why, what you can do with it, why it matters. Now the second part of this is going to be the distributive property and equivalent expressions. Distributive property tells us how to solve expressions in the form of A in parentheses B plus C. So if you've ever got parentheses and then you've got a number outside of the parentheses, it's basically multiplying what's in the parentheses. If you know PEMDAS, you know, the order of operations, you know that you take care of what's in the parentheses first, okay? But this number outside the parentheses will multiply that. So 8 plus 3 multiplied by 4. 8 plus 3 is 11, so 4 times 11 is going to be 44, as this shows. 8 plus 3, 4 times 8 plus 3 equals 4 times 11 equals 44. So that's the order of operations and how we know it, because we know you do the parentheses first. When you do the distributive property, I want you to look at this. Basically, instead of adding these first, it shows that you can multiply both of them by 4, then add them, and come to the same answer. That's called the distributive property. So you can do 4 times 8, okay, plus 4 times 3, and that's what we have down here. 4 times 8 plus 4 times 3. 4 times 8 is 32. 4 times 3 is 12. 32 plus 12 together is 44, so you get the exact same answer as you do when you use the traditional order of operations. This is just what we call the distributive property, and I'm sure you're going to learn much more about that in today's videos and Khan Academy assignment. So just go ahead and work your way through those two things. Hopefully it's more of a day's work for you, and let me know how it goes. I will talk to you later.